Okay, for section B, this section consists of 5 questions of 2 marks each, and we have to solve the first one, that is the question number 21. We have to solve the following system of linear equations. So this is question number 21, and we are going to solve the system of linear equation 7x minus 2y is equal to 5 and 8x plus 7y is equal to 15. So we can solve them by either of the method, that is the substitution of the elimination. I'm going to use the elimination method. So I'm going to multiply this equation with 8 and this equation with 7. So multiplying this equation with 8 gives me 56x minus 16y is equal to 40. And multiplying the second equation with 7, we get it's 56x plus 49y is equal to 7 5, that is 3505. And if we subtract these equations, this gives us, so this is minus 16 minus 49, which is 15, and 4 5 and 6 minus 65y, and this is equal to 105 minus 40 is 65. It is minus 65. This is y. Now y is equal to 1. So y is 1, and if we put y in first equation, that gives me 7x minus 2 into 1 is equal to 5. So 7x is equal to 7 and x is equal to 1. So the value of x and y is 1. And we have to verify our answer. So to verify the answer, we can put the x and y in the first equation and check if the LHS and RHS are equal. So this is equal to 7 into 1. We are doing the verification for x is equal to 1 and y is equal to 1. So 7 into 1 is equal to 5, which is equal to RHS. So the solutions x is equal to 1 and y is equal to 1 satisfies the first equation, and for the second equation is 8 into 1 plus 7 into 1, which is equal to 15, which is equal to RHS. So we have solved and verified the answer. Let's move on to the question number, next question number, which is 22. For question number 22, okay, for question number 22, it's given that in a pack of 52 playing cards, so this is question number 22, and it's given that total cards are 52 and one card is lost. So if one card is lost, that means we have total cards with us is 51. We have to find the probability of queen of heart. So probability of queen of heart. One card is lost and the lost card is a black card. So this black card doesn't affect the probability of drawing the queen of heart, because heart is of red color. Hearts are of red color and we have only one queen of heart. So our option is answer is 1 by 51. Total cards are 51. One is lost and queen of heart is 1. So 1 by 51 is the answer for question number 22. Let's move on to question number 23. For question number 23, we have to evaluate the trigonometric equation that is given. So we are on to question number 23. So I'm going to evaluate the first section, which is 2 root 2 cos 45 into sine 30 plus 2 root 2 cos 30. Now let's put in the respective values of these angles. Cos 45 is 1 by root 2 sine 30 is half. 2 root 2 into cos 30 is root 3 by 2. So this is 1 and this is root 6. So our answer is 1 plus root 6. Okay. This is actually 2 root 3. So this is 2 root 3 into cos 30. So 2 root 3 into cos 30 is root 3 by 2. So that means this is 1. So 1 plus 1 is 2. So 2 is the final answer for part A of question number 23. And moving on to question number part B of the same question, we have to verify LHS is equal to RHS where A and B, angle A and angle B are given. So let's consider LHS, which is sine of A plus B. So sine of A plus B is 60 plus 30, which is sine 90, and sine 90 is 0. Now let's consider RHS. So RHS is equal to is sine A cos B plus cos A sine B. Sine A is sine 60, cos 30, cos 60, and sine 30. Let's put in their values. Now sine 60 is root 3 by 2, cos 30 is root 3 by 2, cos 60 is half, sine 30 is half. So this is 3 by 4 plus 1 by 4, which is 4 by 4, and that's equal to 1. Hence, we have verified that LHS is equal to RHS. Okay, sorry. Here, sine 90 is not 0, but sine 90 is 1. So LHS is equal to RHS. Moving on to question number 24. Okay, for question number 24 is given that in the given quadrant, in the given figure, ABCD is a quadrilateral and diagonal BD bisects angle B and D both. So that means, let's say this is angle 1, this is angle 2, this is angle 3, and this is angle 4. And for question number 4, it's given that BD bisects angle B and angle D. That is, which means angle 1 is equal to angle 2 and angle 3 is equal to angle 4. We have to prove that triangle ABD is similar to triangle CBD. So let's take these triangles, and in these triangles, angle 1 is equal to angle 2, angle 3 is equal to angle 4. Angle 1 is in CBD, and CBD is angle 2 is in angle CBD, and this is ABD. So these are the corresponding angles of both these triangles, and this is because BD bisects angle B and angle D. Now BD, so we have to prove that these are similar. So we can say that by AA rule, because if two angles are two of the corresponding angles of the triangles are equal, then the angles are similar. So by AA, if two angles are similar, then obviously the third two angles are equal. Two of the corresponding angles are equal, then obviously the third corresponding angles are also equal. So by AA similarity rule, we can say that triangle ABD is similar to triangle CBD. And if these triangles are similar, so uh, now for the second part, we have to prove that AB is equal to BC. Now these triangles are similar. Also, these triangles are congruent. So triangle ABD is also congruent to triangle CBD because these two angles, corresponding angles, are equal. Angle 1 is equal to angle 2, angle 3 is equal to angle 4, and BD is equal to BD common. So they are congruent by SASA. So this is because BD bisects angle B and angle D, and BD is equal to BD because it's common. So we can say that by ASA congruence rule, these two triangles are congruent, and which gives us uh, AB. So AB is equal to the corresponding side is BC. So AB is equal to BC, reason being they are the corresponding parts of congruent triangles. Okay, so we are done with question number 24, and moving on to question number 25, we will discuss both the parts, the part A and part B of question number 25. Okay, for question number 25, we have to prove that 5 minus 2 root 3 is an irrational. So this being question number 25. Now 5 minus 2 root 3 is an irrational number. We have to prove that. Let's assume that 5 minus 2 root 3 is a rational number. So let 5 minus 2 root 3 be a rational number. And if 5 minus 2 root 3 is a rational number, so that means I can write it in the form 5 minus 2 root 3 is equal to A upon B, where A and B are co-primes. That means that they do not have any other common factor except 1. So A and B are co-primes. That is, they are not resolved by any other number, any other common number except 1. So these are co-primes. And we have to make sure that B is not equal to 0. So that means if I try to simplify this, I can write it as root 3 is equal to A upon B minus 5. And this has to divided by minus 2, which gives me root 3 is equal to, I can write it as uh, this is minus A minus, let's take B LCM here. So this is A minus 5B upon B divided by 2 is 2B. So root 3 can be written as 5B minus A upon 2B. So root 3 is equal to 5B minus A upon 2B. So here this LHS is rational. Here LHS is rational, but R and RHS, this is, but RHS, sorry, LHS is irrational, but RHS is rational. And it's given that, so if we take the equality, or if we consider this equation, so if this is irrational, it should be equal to something that is irrational. So that means, but here it's LHS is rational and RHS is rational, which is not, which should not happen. So that means that our assumption is wrong. So if our assumption is wrong, and our assumption was that this is an irrational, so that means, so our assumption was that this is irrational, so that means now hence 5 minus 2 root 3 is an irrational number. Okay, so this solves part A, and moving on to part B. I'm going to erase this. So moving on to part B. For part B, okay, moving on to part B of the same question. This is part B, and we have to show that 5 into 11 plus 17 plus 17 plus 3 into 11 is a composite number, and composite number is a number that has more than two factors apart from one and the number itself. Okay, so if I try to take common in these two terms, so this is the first term, this is the second term, and the common is 11. So, and this is actually plus. I do not know this is into, so 11 is common, and I have 5 into 17 plus 3, which gives me 11 into 88. So 11 into 88, and I can write it as into 11 into 2 cube, because if we factorize 88, so this is 244, 222, and 211, so this is 11 into 2 cube. So that means this number can be expressed as a product of two factors other than, so these are the other two factors, 11 and 2. So that means this number can be, this number has this, or the given number has two more factors apart from one, the number itself. And if a number has other factors apart from one in the number itself, then it is a composite number. So it is a composite number. With this, we are done with section B. Let's move on to section C. Thank you for watching.